Hi, you're welcome to my math friend, your favorite math education channel. Let's look at another Olympiad math problem. Okay, it's under this is also an indicial equation. Okay, you see that. Now, what do we do with this? Of course, we have to find the value of x. So 3x exponent x equals 3 exponent x plus 10. Now, you could see that this one can be further expanded. So we have 3x exponent x equals, now this means that, you see, because of the plus, it means that multiplication was applied. So we have 3 exponent x times 3 exponent 10. Because the bases are the same, the powers were added. Very good. You see that? Good. So now that we've done this, what is next? Now we'll find the value of x. We need to be able to group the x's to one side. So you see that we have this on the right. Let's bring it here. So we're going to deal with these three. So what we do, we divide both sides by 3x, by 3 exponent x over here, 3 exponent x as this. Good. So this cancels this. So we see over here. Now what happens over here too? Over here, this is what we have. You can see that we have the 3 here is power 1. Okay. So what we can do is that, you see there is x here. We need to make sure that the coefficient of the x, this base, this x base is 3. It should be dealt with. We're going to remove it from there. So we divide both sides 2 by 3 power 1. So let's write what is left from here. 3x exponent x over 3 exponent x equals, we have this left. So from here, we're going to divide both sides by 3 power 1 to do away with the 3 attaching this. So z divided by, so times 3 exponent 1, here 2 times 3 exponent 1. So this 3 cancels this 3. Good. As you see over there. Now, from here, what do we do? From here, let's write what is left. We have x exponent x out of 3 exponent x down here, which is equal to 3 exponent 10. Now this is division, same basis, so you can subtract their powers. So 10 minus 1. This gives us x exponent x over 3 exponent x equals 3 exponent 9. Good. Now we're on course. What do we do from this step? Now you see that there's a property, okay, of indices, right, that says that if a exponent a, you have a exponent a equals b exponent b, this means that if the base is the same as the power on the left, and on the right you also have the base the same as the power, what you do is that you equate the bases. So we can say that a is equal to b. So there's a property under indices like that. So we are going to represent this in this form. Make sure that the base is equal to the power. So what can we do over here? Now you see that we have the x here is power x, 3 is also power x. So it means that a power x is common. So we bring it outside. We are going to have, this can be written as x out of 3 into brackets all power x. Because the x affects the x, this affects the 3, which is equal to 3 power 9. Now, so from here, we still make sure that we're going to make sure that the bases and the powers are the same. So let's try to multiply each of the powers by 1 out of 3 times 1/3 here, 2 times 1/3. So 3 goes here, 3. So from here, what do we have? We have x out of 3 into bracket, x times 1/3 is x out of 3. This equals 3 power 3. Now, let's compare this to this, our rule. We can see that the base and the power here is the same. Likewise, the base and the power on the right are the same. So with that, we can just equate the bases. So from here, we see that x out of 3 is equal to this 3 over there. This x out of 3 power is equal to the power 3 over here. How do you find x? You cross multiply. You can see that x is equal to 9. Good. And that is the value of x. Very simple. Bye.